Okay, so let's just imagine for a second a world with no roads. No asphalt, no traffic lights, no potholes to dodge. Instead, every single street, highway, and sidewalk is a conveyor belt. You don't drive your car, it just gets carried along. You step outside your door, and the city itself just moves you. It's a pretty wild idea, so let's really get into it.
This whole rabbit hole started with a really great question from a viewer named Tyler. And it's one of those ideas that when you first hear it, you think, wow, that's brilliant. We spend so much of our lives stuck in traffic, right? It feels like there has to be a better way. And maybe, just maybe, this is it.
And the promise here, it's almost utopian, isn't it? Think about it. No more bad drivers, no more stop-and-go frustration, no more human error causing accidents. You'd have a city that just flows. Perfect, elegant efficiency. Just pure, uninterrupted motion. But, as we're about to find out, the second you synchronize everything perfectly, you stop being a commuter, and you start being a major problem for the laws of physics.
All right, so here's our roadmap for this. We'll start with that dream of the perfect commute. Then we'll see what happens when physics enters the chat. We'll look at the logic of collapse, how we humans would inevitably break the machine, the staggering price of all this motion, and we'll finish with something you might not expect, the freedom to just stop.
For the first 5 minutes you think about this, the idea is just a work of genius. On paper, it really is a transportation engineer's dream. People are just gliding to work, groceries are delivered in this constant stream, and cars, they just merge into a perfectly ordered flow. No more road rage, no more congestion. It's beautiful. So, the way it would work is with these layers of speed. You'd start on pedestrian belts, moving at a nice, gentle walking pace. Then next to those, you've got your side roads for local traffic, cruising at a steady 20 kilometers per hour. And then you get to the main arteries, the highways, flowing at a pretty brisk 40. See, in this world, cars don't really accelerate or brake. They're just carried. They merge from one belt to the next. And on paper, it looks like a perfectly clean, super efficient solution that could solve transportation forever. And then reality kicks in. Hard. This is where that elegant dream smacks right into the harsh laws of the universe. Because, well, while the concept seems simple, the actual physics of moving an entire population on the ground beneath their feet is anything but. So let's talk about the first huge problem, acceleration.
So you can't just have one single belt moving at highway speeds. It's just not possible. Why? Well, imagine stepping from a complete standstill onto a surface that's already moving at, say, 60 miles per hour. That would deliver a violent, instantaneous shock to your entire body. The source material had a great way of putting it. It's like the entire Dallas Cowboys team running full tilt into your neighbor's garage. That's not a commute, that's a full-on impact event.
Okay, so the logical solution, right, is a series of belts. Each one moves just a little bit faster than the last. So you'd hop from the 5-mile-per-hour belt to the 10, then you merge onto the 20, and so on. You're gradually accelerating. But wait a minute. In doing this, we've just reinvented traffic lanes. The only difference is now they're moving and there are absolutely no brakes.
But that's not even the worst of it. What happens when these belts need to take a turn? Follow the curve of a road? Well, the centrifugal force at those higher speeds would be immense. It would literally pin you against the guardrails with crushing force. And this is the point where, as the source material so vividly puts it, your skeleton becomes luggage that regrets its life choices. Okay, and this is where the problems really start to compound. The system's greatest strengths, that constant speed, that synchronized motion, they also turn out to be its greatest weaknesses. They create this terrifyingly fragile logic where one tiny failure can cascade into a total citywide collapse. Think about it like this. Falling down on a normal sidewalk? Yeah, it hurts. But falling on a moving surface is a whole different ballgame. You don't just hit the ground. The ground then grabs you and carries you away, dragging you along until you slam into something that isn't moving. A simple trip and fall instantly becomes a really serious accident. And here's the crucial point. We've completely removed individual control. You can't brake. Your car isn't really a car anymore, it's just cargo. So if something goes wrong, a car stalls, someone has a medical emergency, you can't just pull over. The only way to stop is to shut down an entire section of the belt. And until that happens, every single person, every single vehicle behind that obstacle is on an unavoidable collision course. And then you get to intersections. And this is where the whole concept truly fundamentally dies. Just think about it for a second. You have two belts crossing at a right angle. One is moving north, the other is moving east. What happens where they meet? It's not a simple crossing. If both belts keep moving, you create these immense shear forces at the collision point, forces that would literally tear people and vehicles apart. Intersections can't exist anymore. They have to become these perfectly timed, impossibly complex mergers.
And a perfectly timed system like that is also incredibly fragile. The whole thing depends on perfect, predictable flow. There's this one witty observation from the source material that just says it all. This is the only kind of infrastructure where stopping to tie your shoe becomes a full-blown civil engineering incident. Any tiny, unpredictable human action could disrupt the entire grid.
Which, of course, brings us to the biggest, most unpredictable variable in this whole equation. Us. Humans. See, this entire system is designed for predictable objects, like boxes moving around a factory. But people aren't boxes. We're chaotic, we're unpredictable, and we consistently refuse to behave like identical pieces of cargo.
I mean, we stop suddenly, we change our minds, we drop things, we panic, and what about people who need a little help? How does someone in a wheelchair or a parent pushing a stroller navigate a series of constantly accelerating platforms? And then you have to add weather into the mix. Rain makes the belt slick, snow and ice would cause absolute, total chaos. You can't exactly salt a continent-spanning machine.
And emergency services, they become a logistical nightmare. An ambulance can't choose its own speed, the road dictates it. Fire trucks can't weave through traffic because there isn't any traffic, just a solid, moving mass of vehicles. To get to a single emergency, you'd have to shut down the belt for an entire district, stopping thousands of people in their tracks. Responders would literally have to run against the motion or just wait for the ground to cooperate. And those minutes of delay, they turn a single incident into a catastrophe.
All right, so let's set aside the physics and the human problems for a second and just talk about the price tag. What would it actually cost to build and run this planetary-scale machine? The logistical and resource costs, they are so astronomical they are almost impossible to even comprehend. First, let's talk about just powering the thing. The estimates suggest that keeping all the world's roads in constant motion would require literally thousands of nuclear reactors. And that's not peak demand, that's the baseline. It's a continuous, never-ending power draw. The system is burning massive amounts of energy constantly, even at 3 a.m. when maybe nobody is using it. It might be the first transportation system in history where just standing still costs more than moving. And then you have to maintain it. Look, roads are static. They crack, they get potholes, sure, but they're fundamentally passive. These belts, though, they're active machines. They tear, motors overheat, sensors glitch. A single loose bolt is a major hazard. Right now, a closed lane on a highway is an inconvenience. But in this world, a single stopped belt is a catastrophic system failure that creates an instant, unavoidable pile. But you know, the real cost here isn't something you can measure in dollars or megawatts. It's something much more fundamental. The true price we would pay for all this supposed efficiency is our own agency, our simple ability to choose. And this really gets to the heart of it. In a world like this, you lose all control. You don't get to choose when to slow down or where to turn or when to just stop. The city makes all of those decisions for you. You are no longer a person traveling through a city. You are an object being processed by it. And that really sums up the final takeaway here. Look, our current system is messy. It's inefficient. And yeah, it's often incredibly frustrating. But it's also forgiving. It allows for human error, for changes of plan, for the simple, beautiful freedom to just stop and look around. The conveyor city is efficient, but it's rigid. It's procedural, not navigable. It traps you in constant motion, while our world, for all its faults, gives us the freedom to stop. In the end, roads work not because they move us, but because they patiently wait for us to move ourselves. So, Tyler, it was a fantastic thought experiment. A brilliant one, really. But it seems like replacing our roads with conveyor belts would turn our messy, forgiving cities into rigid, incredibly fragile machines. So that brings us to the end. And if you've got a question that sounds ridiculous but just won't leave your brain alone, we'd love to hear about it. Leave it in the comments. Let's keep asking.